Unigine provides high-quality water simulation with complex behavior and ability to interact with physical bodies out of the box. Different types of water basins from oceans and natural lakes to pools and puddles are at your disposal. This tutorial covers general aspects of creation and configuring the visual representation of water objects. Advanced setup, including physical simulation, is a subject of dedicated tutorials. Water in Unigine can be simulated with either of the two types of objects that use special shaders for realistic rendering. Water mesh is a mesh used to create finite basins of arbitrary form and height. You can create as many water meshes as you need and place them at desired locations. Global water represents a boundless ocean limited to a single water level. It is an infinitely spread mesh featuring auto-tessellation to ensure an impressive level of detail. Underwater mode and shoreline simulation are also available. Improve the look of your landscape using the Water Global object. Choose Create, Water, Global, and adjust the level of the water surface. Make sure that water rendering is enabled in the Rendering Water menu. Enable screen space reflections to make the look of the water surface more realistic. The effect can be adjusted in the global water settings. Choose Windows, Settings to open them. You can choose Quality of SSR and use the SSR Increased Accuracy option for better visual look at the cost of performance. At this stage, we have already got a nice-looking water. By default, it has the Water Global base material applied. You can simulate different sea conditions according to the Beaufort scale up to the 12th level by using preset Water Global Beaufort materials. All visual adjustments are made in the material settings. The default material is read-only, so let's inherit a child material from it and adjust its parameters. All water settings are divided into several groups of parameters. The material mask serves for filtering through decals that are projected onto the water surface. Decals that are suitable for interaction with water are available in the Create Water menu. Check out our video tutorials on bit masking and decals for more information on when and how to use them. Geometry parameters enable you to adjust triangulation settings. By increasing the max tessellation factor, you make the surface much smoother and heavier for rendering. Tessellation exponent determines how fast the factor changes with the distance. The radius of the tessellated area is defined by the tessellation distance parameter. You can also adjust the look of procedural surface distortion via the procedural normal blur and wakening parameters. Choppiness parameters define sharpness and look of wave crests. Adjust them or uncheck the choppy wave state if you don't need to simulate sharp waves. Turbulent water surface rippling and dynamic waves are done by animating and blending several layers of a single normal detail map and the height texture respectively. The height texture defines the look of dynamic waves. You can use it to give waves custom look. Control the intensity of each detail layer in the Waves Animation group. UV Transform is available for each detail layer. Define the scale along the X and Y axis. You can also adjust wind force and direction via the offset parameters that define the offset of the map along the axis in units per second. Water intersecting any geometry forms procedural foam based on the foam texture. The engine samples the texture with two patches. Their size and speed are available for adjustment and can be used, for example, to add more detail. Overall foam intensity is controlled by the intensity parameters. The Subsurface Scattering group controls the effect of light scattering when passing through water. You can adjust color, overall intensity, intensity through waves and around foam, and intensity for diffuse lighting. Underwater parameters define the look of the underwater environment. You can make it look more or less deep using the fog transparency parameter. Fog lighting depth defines how deep diffuse lighting goes through the water. Objects placed deeper than this value will not be lit. You can fine-tune the depth by adjusting the lighting offset parameter. The depth LUT texture defines the color of the underwater fog depending on the depth. The right side of the image shows the color of the deepest areas. You can also define the color multiplier for the underwater fog and how much sun and environment affect it. It's easy to adjust underwater lighting and apply special effects such as underwater sun shafts. You can enable it via the Rendering Water menu and control intensity via the corresponding materials parameter. You can also control the size of the borderline between the overwater and underwater areas. Underwater mode includes the underwater depth of field effect, an additional blur for underwater and overwater splice to make the waterline look more plausible. The look of water surface is configured by the following group of parameters. You can adjust roughness of environment reflections to add distortion to the environment reflection. Reflection occlusion handles parts of the surface with negative normals. Using this parameter, you can get rid of too bright areas on waves close to the horizon. Refraction Scale stands for the intensity of water surface refraction. Refraction quality can be selected in the global water settings. The strength of diffuse lighting distortion is controlled by the diffuse distortion parameter. Use the soft intersection parameter to control the sharpness of transition between water and any other geometry, such as the shore. Water simulation also includes the Caustics Effect, turbulent highlights cast by waves from the surface. The 3D caustic texture is projected onto the bottom and animated, providing a convincing effect. The effect is configured via the corresponding group of parameters: UV transform for the texture, depth at which the effect is visible, speed of animation, and brightness. You can control dynamic planar reflections on water via the States tab. Don't forget to enable dynamic reflections in the rendering menu. Map size here defines the quality of reflections. Other settings are available via the usual planar reflection parameters. For example, you can define objects to be reflected via the reflection viewport mask. Remember that planar reflections is a very consuming effect and may significantly drop performance since it doubles the geometry rendered. You can use faster screen space reflections instead and combine these effects. For more details, refer to the Content Optimization tutorial. The Water Global Object supports interaction with field spacers and with other types of fields as well. You can use a field spacer to cut out water from areas where it shouldn't be visible. For example, this boat's deck. Enable the field spacer interaction flag of the water material in the States tab and place a new field spacer object right inside the boat. Adjust its shape and the attenuation value. This will prevent the water from appearing inside the boat even if the deck is lower than the water surface. You can choose a box or an ellipsoid shape of the field spacer depending on which fits best. Now the water surface inside the field is not rendered. You can do the same to remove water from certain landscape areas. The field height object represents a volume defining areas where height of the water surface should be modified to simulate water disturbance in wake fields. Create a field height object using the water section of the creation menu and adjust its size. Field height has the field mask, just like other fields. So, to be applied to water, this mask must have at least one matching bit with the physics field mask of the water surface. The applied texture is treated as a height map and affects the water surface geometry. Use the power parameter to adjust the intensity of the effect. You can also set the attenuation factor, indicating the rate of gradual change in height from the center of the field. Depending on the blend mode, the height map will be either added or multiplied to the height of the water surface. Thus, you can achieve different results. You can blend several fields together. Use the order parameter to define the sequence the fields are applied in. All field height objects are also rendered in one buffer. You can change its resolution via the field height resolution parameter in the global water settings. Remember, increased texture resolution affects performance. Then let's emphasize the sharp bow of the boat, as it should cut through water in front of the boat by applying a corresponding texture. A moving boat leaves disturbances behind because its motor is in operation. In addition to the field height, Unigine provides a field height particles object with a procedurally generated height map based on a particle system that can be used to simulate such disturbances. Well, let's configure the particles to make them appear right near the engine and run away from the boat. Particle size and lifetime adjustment may also be required. You can also use several particle systems for a single field height. Particle-based water decals are also supported. To create an effect of foam trail, let's choose Create Water Decal Particles. Place the object under the engine and adjust the look and behavior of particles. Then apply the corresponding textures, and that's it. We've got a realistic-looking boat with convincing water surface interaction and a wake field. Field Shoreline is intended to create a realistic coastline where the global water meets the terrain. Right now, the shoreline looks unnatural. The water just ignores the land. Choose Create, Water, Field Shoreline, and cover the whole shore with it. Don't forget to enable Field Shoreline Interaction flag of the water material. After that, choose the texture resolution, adjust blurriness of the shoreline, padding distance from the shore to the beginning of swash, and click Grab to save the shape of the shoreline to a texture. This will result in waves easing by the land and procedural swashing within the field object area. Now the shoreline looks much more convincing. All field shoreline objects use the same buffer. You can choose its resolution via the Field Shoreline Resolution parameter in the global water settings. However, keep in mind that increased resolution significantly affects performance. To improve the look even more, you can use the Procedural Shoreline Wetness effect applied to any geometry that is immersed in the water. For fine-tuning of the shoreline look, use shoreline parameters of the global water material. You can control speed and tiling of waves, adjust foam, and shoreline wetness parameters. Customize the shape of waves in wetness areas using the Shoreline LUT texture. You should pay special attention to the parameters defining the geometry of waves. Wave mode lets you choose the wave's height. Falloff defines the speed of the wave falloff, and the Beaufort falloff parameter defines the amount of attenuation for Beaufort waves near the shore. By default, shoreline waves have geometric nature. In case this geometry is excessive, for example, the scene is observed from high above, and the difference is not perceptible. You can disable the geometry flag to keep water surface flat and save some performance. You can also disable foam and keep only geometric waves. If you simulate pretty high waves, you might need to calculate normals for the water surface for proper visual look. However, this option significantly reduces performance. Enabling just the geometry state to simulate distortion of the water surface is enough in most cases. You should keep the high precision state enabled if your camera is intended to dive into water, so the waterline separating overwater and underwater is visible. This feature enables improved interpolation between the adjacent pixels of the shoreline texture to reduce stepping artifacts. Post-processing is available for the water global material as well. You can enable post effects for the front and back faces separately. Global water settings are intended for general water adjustments in the world. You can set the anisotropy quality of the water texture, define whether to render lights, environment, and voxel probes on the water surface, as well as whether the water is to be rendered to the opacity depth screen buffer for additional post-processing. And if you need increased rendering precision for field objects here, you can enable the Field Precision 32 bits option. Only one global water object can be added to the scene, so if you need to create water above or below the sea level, you should use Water Mesh. To create such objects, you can use any mesh that meets the following requirements. The mesh should be flat and have a uniform grid. The mesh should be oriented strictly along the axis, and the mesh must have a correct UV layout to make water surface ripple credibly. Shift and right-click in the viewport. Choose Water, Mesh, and select your mesh asset, for example, the content of an FBX model. After that, just position the object on the terrain. You can also use a plain primitive instead of FBX. Reset the position of the node and choose Create Mesh in the right-click menu. Now you can create a new water mesh object using the exported mesh that fits all requirements. Different kinds of waves can be simulated with 4 directional geometrical waves, animated in the vertex shader. Each layer is set independently, which enhances flexibility of adjustment. You can adjust the direction, length, speed, and amplitude for each wave layer. Enable the Object Wireframe Helper to check the effect. The final quality depends on how detailed the mesh is. Use Waves Radius to control the radius of waves. The water mesh material has almost the same parameters defining water appearance as the water global one. However, there are some specific features. By default, turbulent water surface rippling is done by animating and blending 5 layers of a single normal detail map. But if you don't need that many, you can use only 2 by disabling the Additional Details state. UV Transform is available for each detail layer. As rippling simulation uses normal mapping, the scale of the mesh affects the appearance of water waves. Realistic water simulation is a very broad topic. In this video, we've just touched on the basics of creating water in Unigine and adjusting its appearance. Physical simulation and other aspects are subjects of dedicated video tutorials. For more details, please refer to our online documentation.